is spinning once every 5.5 hours. That means the front edge is moving at about 50 meters per hour, as fast as it is, as though it's creating artificial gravity. What's your take on that planet that's supposed to be outside the Kuiper Belt? Planet 9. So far, yeah, I think all the data looks convincing. As we venture beyond the familiar planets of our solar system, the Kuiper Belt and the Oort cloud emerge as two fascinating and mysterious regions. These distant zones are home to icy bodies, dwarf planets, and the origins of many comets. Yet they are also shrouded in mystery. With NASA's New Horizons spacecraft providing groundbreaking data, new discoveries are reshaping our understanding of the Kuiper Belt, its possible size, and its role in the solar system's history. Meanwhile, the Oort cloud, though never directly observed, continues to intrigue scientists with its theoretical significance as the edge of our solar system and a link to interstellar space. The Kuiper Belt is a vast, donut-shaped region of icy bodies that surrounds our solar system, beginning at the orbit of Neptune, about 30 astronomical units, AU, from the Sun. For reference, $1 is the average distance from Earth to the Sun, approximately 93 million miles. This region stretches outward to about $1,000, making it one of the most extensive structures in the solar system. The Kuiper Belt is home to a variety of icy objects, including dwarf planets like Pluto, Haumea, and Makemake. It contains remnants from the early solar system, objects that never coalesced into planets due to the gravitational influence of larger worlds like Neptune. The Kuiper Belt's structure and composition offer scientists a glimpse into the conditions that existed during the solar system's formation. Interestingly, the Kuiper Belt has two distinct regions. The inner Kuiper Belt is more densely populated and relatively stable, resembling the asteroid belt between Mars and Jupiter, but on a much larger scale. Objects here, such as Pluto, tend to have well-defined orbits. Beyond the inner region lies the scattered disk, a chaotic zone extending toward the edge of the solar system. This region has erratic orbits that are still evolving. Objects in this region are less densely packed, and much about it remains unknown. NASA's New Horizons spacecraft, famous for its historic flyby of Pluto in 2015, continues to explore the outer reaches of the solar system. During its journey beyond Pluto, New Horizons made a surprising discovery that challenges our understanding of the Kuiper Belt's size and structure. As the spacecraft traveled between $45 and $55, it detected higher-than-expected levels of dust and Kuiper Belt objects, KBOs. This finding contradicts previous models that predicted a significant drop in both dust density and object population in this region. The results suggest that the Kuiper Belt might extend farther than initially thought, with the inner Kuiper Belt possibly reaching as far as $80. Alternatively, there could be a second, previously unknown Kuiper Belt beyond the scattered disk. If confirmed, this discovery would reshape our understanding of the Kuiper Belt's structure and dynamics. It also raises intriguing questions about the distribution of material in the outer solar system and how these regions interact with interstellar space. While the Kuiper Belt marks the outer edge of the solar system's disk, the Oort cloud is a spherical shell of icy bodies that surrounds the entire solar system. The Oort cloud begins where the Kuiper Belt ends, at approximately $2,000 from the Sun, and extends to about $100,000 or 1.5 light-years. It is so distant that it resides in interstellar space, far beyond the influence of the Sun's gravity. Unlike the Kuiper Belt, the Oort cloud is entirely theoretical. No objects within it have been directly observed. Scientists infer its existence from the behavior of long-period comets, which are thought to originate in this region. Long-period comets take more than 200 years to orbit the Sun, in contrast to short-period comets like Halley's Comet, which are believed to come from the Kuiper Belt. The Oort cloud is thought to have formed from planetesimals, small icy bodies that were flung outward by the gravitational influence of the giant planets during the early solar system. While the Kuiper Belt remained relatively close to the Sun, the Oort cloud objects were pushed to extreme distances, where they are now held in place by the gravitational pull of the Milky Way galaxy. The Kuiper Belt is believed to be one of the oldest surviving remnants of the solar nebula, the massive cloud of gas and dust from which the Sun and planets formed about 4.6 billion years ago. Initially, Scientists theorized that the Kuiper Belt might have contained enough material to form a planet, but this did not happen due to the gravitational influence of Neptune. Neptune's presence disrupted the orbits of objects in this region, preventing them from coalescing into a single large body. Instead, these icy fragments were left to form a diffuse belt of debris. Some scientists also proposed that Neptune's migration outward from its original position scattered much of the Kuiper Belt's material into interstellar space, leaving behind only a fraction of the original mass. According to the NICE model, a leading theory for the Kuiper Belt's origin, the giant planets, Jupiter, Saturn, Uranus, and Neptune, did not form in their current positions. Instead, they migrated over time, with Jupiter and Saturn moving slightly outward and Uranus and Neptune being pushed into the icy outer regions of the solar system. This migration caused a gravitational upheaval that flung smaller objects outward, creating the Kuiper Belt as we know it today. The NICE model also explains the peculiar orbital relationship between Pluto and Neptune. Pluto, a prominent Kuiper Belt object, is in a 3:2 resonance with Neptune, meaning that for every 3 orbits Neptune completes around the Sun, Pluto completes 2. This resonance helps stabilize Pluto's orbit, preventing collisions with Neptune despite their overlapping paths. Given its size and structure, some scientists speculate that the Kuiper Belt might have been the building blocks of a failed gas or ice giant. Without the gravitational influence of Neptune, the material in this region might have come together to form a planet similar to Uranus or Neptune. However, Neptune's gravity disrupted the region, preventing this from happening. Despite its vastness, the Kuiper Belt is surprisingly sparse in terms of mass. The total mass of all known Kuiper Belt objects is estimated to be only about 10% of Earth's mass. This raises questions about where the missing material went. Some of it was likely ejected from the solar system during the chaotic early years of planetary formation, while other parts may have collided and broken apart into smaller fragments. The Kuiper Belt and the Oort cloud are 2 distinct regions of icy bodies in the outer solar system that differ significantly in structure, origin, and location. The Kuiper Belt is a flat, donut-shaped disk lying within the plane of the solar system, located between 30 and 1,000 astronomical units, AU, from the Sun. In contrast, the Oort cloud is a spherical shell that surrounds the solar system in all directions, beginning at around 2,000 Australian dollars and extending to 100,000 Australian dollars. The Kuiper Belt is the origin of short-period comets, which complete their orbits around the Sun in less than 200 years, while the Oort cloud is the source of long-period comets, whose orbits exceed 200 years. Another key difference is observability. Kuiper Belt objects, such as Pluto and Eris, have been directly observed, whereas the Oort cloud remains theoretical and has not yet been directly detected. NASA's New Horizons mission has provided invaluable insights into the Kuiper Belt and its potential boundaries. With enough propellant to continue operations into the 2040s, the spacecraft may uncover more surprises about the size, structure, and composition of this distant region. Meanwhile, advancements in telescope technology and future missions may one day confirm the existence of the Oort cloud and provide a deeper understanding of its role in the solar system. For now, these outer regions remain some of the most enigmatic and exciting frontiers in space exploration. In exploring the Kuiper Belt and the Oort cloud, scientists are not only uncovering the history of our solar system but also gaining clues about the formation of other planetary systems across the galaxy. As our understanding grows, these distant regions may reveal their secrets, bringing us closer to understanding the universe as a whole. As our technology improves, the study of distant regions in our solar system, such as the Kuiper Belt and the Oort cloud, continues to evolve. These regions are crucial to understanding the formation of our solar system and, more broadly, the processes that govern the creation of planetary systems throughout the universe. One of the most exciting aspects of studying these outer reaches is the potential to discover new objects, previously unknown bodies, or even new types of celestial phenomena. These discoveries not only broaden our knowledge but also challenge our current models and theories about the formation and evolution of planetary systems. One fascinating aspect of the Kuiper Belt and Oort cloud is the way they connect our solar system with interstellar space. The objects in the Kuiper Belt are not only remnants from the early solar system but may also serve as a bridge between the Sun's gravitational influence and the vastness of the Milky Way galaxy. The fact that the Oort cloud is located so far from the Sun means that it exists in a region influenced by the galaxy's gravity more than the Sun's. This connection between the solar system and the galaxy provides valuable insights into the interactions between solar systems and the broader cosmic environment. As the New Horizons spacecraft continues its mission, it provides more detailed observations of the Kuiper Belt and its objects. This includes studies of the composition, size, shape, and orbits of objects in the region. In particular, one of the goals of the mission is to better understand how the material in the Kuiper Belt has remained largely unchanged since the solar system's formation. This provides a snapshot of the early solar system and offers clues about how planets, moons, and other objects formed in the distant past. NASA's ongoing efforts to explore the outer solar system also include the study of other distant objects like Sedna and Eris. Sedna, a distant KBO, orbits the Sun at an extreme distance and has a highly elliptical orbit. Its orbit takes it far beyond the Kuiper Belt and into the distant reaches of the solar system, making it one of the most intriguing objects discovered so far. Eris, on the other hand, is one of the largest known dwarf planets in the Kuiper Belt, and its discovery helped redefine the boundaries of the solar system. Eris and its moon, Dysnomia, are similar in size to Pluto, making them prime candidates for further study in understanding the diversity of bodies within the Kuiper Belt. The Kuiper Belt is also important in the study of cometary activity. Short-period comets, which originate in the Kuiper Belt, provide important data about the early solar system's chemical makeup. These comets are often made up of a mixture of ice, dust, and rock, and their study can reveal information about the conditions that existed in the outer solar system billions of years ago. Scientists are especially interested in how the composition of these objects may vary, depending on their location in the Kuiper Belt. By examining these objects, astronomers can learn more about how the Sun and the planets formed and the role that external factors such as radiation pressure and gravitational interactions played in shaping these bodies. The Oort cloud, though still theoretical, remains a region of immense interest to astronomers. While we have yet to directly observe the Oort cloud, its effects on the behavior of long-period comets are well documented. These comets often come from the Oort cloud and have orbits that take them far beyond the Sun's influence. Their long, elliptical orbits bring them back into the inner solar system after hundreds or even thousands of years. Understanding how these comets form and how they travel through the solar system is crucial to understanding the broader dynamics of our cosmic neighborhood. One of the key challenges in studying the Oort cloud is that the objects located within it are incredibly distant and faint. Even the most powerful telescopes cannot easily detect these objects directly. Instead, scientists rely on indirect methods of detection, such as tracking the movement of long-period comets and observing their trajectories. These comets provide a trail of information that helps scientists infer the location and distribution of the Oort cloud. The Oort cloud's immense size and distance make it difficult to study, but it also makes it an exciting frontier for astronomers who are eager to learn more about this enigmatic region. The search for Planet 9 is another fascinating mystery that could change our understanding of the outer solar system. Planet 9, if it exists, would be a large planet located far beyond the orbit of Neptune. Its existence is still theoretical, but astronomers have observed unusual gravitational influences on objects in the Kuiper Belt that could be explained by the presence of a massive planet. If Planet 9 is eventually discovered, it would be a groundbreaking moment in the history of astronomy. This discovery would shed light on the formation of our solar system and the dynamics of the outer solar system, as well as potentially expanding our knowledge of planetary systems beyond our own. In addition to theoretical studies, the Kuiper Belt and Oort cloud also offer a unique opportunity to explore the possibility of life beyond Earth. The chemical compounds found in comets and other icy bodies could provide clues about the building blocks of life. Some scientists speculate that organic molecules, including amino acids, may be present on comets that could have played a role in the origins of life on Earth. The exploration of the Kuiper Belt and the Oort cloud could, therefore, offer valuable insights into astrobiology and the potential for life elsewhere in the universe. Advancements in technology, such as the development of more powerful telescopes and spacecraft, will continue to expand our ability to study these distant regions. As our understanding of the Kuiper Belt, Oort cloud, and other distant parts of the solar system grows, we will likely uncover more secrets that challenge our current understanding of the universe. These discoveries will not only deepen our knowledge of the solar system's history, but will also provide critical clues about the processes that drive planetary formation and the potential for life beyond our planet. As we continue to study the Kuiper Belt and Oort cloud, we are reminded of how much remains to be discovered in the farthest reaches of our solar system. These regions, though difficult to study, offer tantalizing glimpses into the past, present, and future of our solar system. Their exploration holds the promise of exciting new discoveries that will further our understanding of the universe and our place within it.